Now that we have the rig applied to our envelope, we're just about ready to export it and then make any last adjustments before we can actually run around inside the game. First, we just need to make a copy of our texture in the source SDK. So navigate to DB201, Pictures, and copy the nsc.tga, and let's place it under Program Files, Steam, Steam Apps, User, Half-Life 2, Deathmatch, HL2MP, Material Source, and just paste your TGA right in there. Now we'll leave it there for a second before we compile. But what I'm going to do is copy the entire file path of that folder and then go to the model and assign it that same directory to reference the texture. File, External Files. And there's one here called Pictures nsc.tga. Under User Path, replace the Pictures folder with the file path we copied. Good. Now our texture location is properly referenced. And next, we'll actually export the model. Since we are planning to use the default animation library that ships with Half-Life 2, we'll export our new model to the directory for humans in the SDK. Select the model, go to Valve Source, Export SMD, take a look at the file path, and let's make sure it points to the source SDK content, HL2MP, model source, humans, male, group 03M. And we're going to save it right there. Name it NSC. Make sure that you have Steam running, and we'll export. Let's go ahead and open another window. And navigate back to the SDK content, model source, humans, male, group 3M folder. You'll see our new SMD in there. So next, we'll want to compile the texture. Locate the vtex.exe program in your Steam Apps, username, source SDK, bin folder. And we'll want to drag the TGA texture to the vtex program. It may be easier to create a shortcut for it on the desktop since we're going to be using it more later. And we'll do the same with the studiomodel.exe. That's the program we're going to use to compile our model. Now, open up the Half-Life 2 Deathmatch Materials folder. That way we can see our texture appear once we compile. Grab your Photoshop TGA texture and drag it to the vtex.exe. It'll take a few seconds to compile. There you go. We have the compiled texture. Now, we have to generate a material for that texture. So let's make a new folder, call it NSC. And inside, we're going to create a text file called nsc.vmt, which will be our material. A good idea is to assign the VMT files to open with Notepad. That way they'll always open with Notepad, and it'll save you a few steps down the line. Here we have to write a few lines that will describe the type of material and the texture that will be used for our model. In DVD Extras, in the NSC folder, I've already created that material for you. To use it, just copy the text contents and paste it in the material. It's given the illumination type and the texture name. The next step is to create a similar file for the model, not the texture, to reference. We spoke about this file, the QC file, earlier on. It's the same thing. In the Extras folder, I provided an NSC QC file. Copy it into your Group 03M folder and open it up. In the .qc, you'll find the name of the model up top, the name of the .mdl model file that will be generated, and the name and location of the materials for the model to use. There are also different eye and body controls, and important rules for how our model will act within the game and how it can be affected. Remember, we are still using the pre-made animation library, so pay attention to the HL2MP models folder and drag nsc.qc to the studio model.exe program. It should create an NSC folder within the models folder. Inside the NSC folder, you'll see the .mdl, which is our compiled model. So let's right-click and tell it to open with Steam, Steam Apps, User, SDK, Bin, and tell it to open with the model viewer, hlmv.exe. If you double-click it, it will now open in the model viewer and should show our NSC model with the correctly applied textures. Inside the model viewer, you have access to the entire standard Half-Life 2 animation library. With your left mouse button, you can orbit the camera, and with your right mouse button, you can zoom in or out on your model to inspect how everything is working. To show you how important it is that everything is placed in the correct folders, I'm just going to move our material out of its correct folder. Then if I open up the model in the viewer by double-clicking on the model, it comes up with this pink and black texture. This is the default something's wrong material that lets you know that it can't find the correct texture. So it's very important that all your folders be well referenced and in order. Where the model is, where the materials are, and where the texture is. Now that we have everything in order, and we've checked our new model in the model viewer, we're incredibly close to playing inside the game. There are a couple optimization methods we can use, however, to ensure that once we're in the game, our model appears as best it can without overusing system resources. So let's talk about LOD, or level of detail. LOD signifies the level of detail or number of polygons or triangles we will have within a model. Open a scene, go to DB201, Scenes, NSC Rigged. This will allow the engine to process the number of triangles much faster. Now let's stop quickly and adjust our display options to uncheck X-ray mode. There we go. Conforming my model to the placement of the camera should automatically change the number of triangles. For example, right now my model has 5,400 triangles. If I move the model further away, I'm not necessarily going to need as many triangles to keep the detail. So what a level of detail does is allows the engine to process the number of triangles faster. Conforming the model to the placement of the camera automatically changes the number of triangles depending on how far the camera is away. To create the different detailed versions of models, if we use the complete version of XSI, we're going to use what's called the polygon reduction tool. Or we're going to use the filter polygons tool if you're using the XSI mod tool. For now, we're going to work with the polygon reduction tool from version 5. With the model selected, we can go to Modify, Polymesh, and select Polygon Reduction from near the end of the list. When this opens, the default ratio will change to 50% of the number of triangles to around 2,500. You can still see the detail pretty well here. Now I can work at this level until I can no longer see the detail. Here we are at 0%, which is 5,400 triangles. And you can see how the number of triangles reduces as I step up. We'll work with the LOD controls. Here, we start with a default of 0, which is 5,400 triangles. And at stage 1, it reduces to 2,500. This is because we're working at a 50% reduction ratio. Now, every time I raise the number, it will reduce 50% of the triangles. But at higher stages, you can see that most of the character's detail has already been lost. What we're going to do is change the reduction ratio to 25%. This way, 1, 2, 3, 4, 5. We can export 5 models, and we only drop from 5,000 triangles to about 1,000 triangles, reducing 25% at each stage. So let's leave it at 0, which is our original model, and we'll export an SMD at each LOD stage. Valve source, export SMD, navigate to C, program files, Steam, Steam apps, your username, source SDK content, HL2MP, model source, humans, male, group 3M. And here, we're going to save it as NSC. Let's go to level 1 of our detail. That reduces 25% of the polygons, and we export. The file location is going to be the same, except we're going to add underscore LOD underscore 1. And we export. That's the first level. We export the same way with stage 2. Same with 3. 4. and 5. If you don't have access to the polygon reduction tool, you could go by hand and reduce the number of triangles and polygons by erasing edges, which could definitely take a lot of time. Or you can use the filter polygons tool, which works similar to the polygon reduction. Once I start working, you'll see the change in detail. And I haven't reduced quite as many polygons, but it still works. Go to polygon areas, and we start to lose a lot of detail, but with a little patience it could work okay. Now, in the Program Files folder, Steam, Steam Apps, Neosis, or your username, Source SDK Content, Model Source, Humans, Mail, Group 03M, this is the QC file that I've originally used to compile. If we use it again, we still wouldn't incorporate any levels of detail. In the Database Extras folder, NSC, under Compile Items, I have an NSC LOD QC file. It looks pretty similar to the one we were using before, but what I'm looking for are a couple of lines that read LOD7. This implies 7 metric units for the camera. Here, it will be at a level of detail 1. With twice the distance, it moves to level 2, 24, level 3, 35, level 4, and 60, level 5. These are metric units to the camera, and these are the only instructions that we care about. So let's compile using this new LOD QC. It's loading the 6 models, and it's starting to compile. In the meantime, I'm going to open another window. The SDK compiler is taking all the assets, our model, our texture, the animations, as well as the specific instructions that we've given and the attributes that we've outlined, and bringing them all together to create our character. Looks like it's still compiling. So let's navigate to Half-Life 2, Deathmatch, HL2 MP, Models, NSC. And as soon as it's finished compiling, open it up with a model viewer. Switch to the Model tab. And here we have our Auto LOD. We have 5,400 of the original polygons. Now if I zoom in or out, it keeps the same number of polygons. So let's activate the Auto LOD. And now if I zoom in, we get to level 0 with 5,400 triangles. And if I zoom out to 7 metric units, it changes the level of detail to one with 3,900 triangles. There's level 2. 3, 4, up to 1,500 triangles. This is great because when the model is far away, we really don't need as much detail. So it can really help the frame rates, moving smooth throughout the game. And because the switch is automatic, it's really tough to see it happening, especially inside the game with multiple characters, running around and blowing stuff up all around you. You don't notice, but it really does help performance. Good. We've now seen how to create a 3D character, create a rig, export it, and then import it into the model viewer. Now we'll explain how to play your character in the game. To use our own character in Deathmatch, we have to replace the default characters that come with the game. This can be as many as 19 characters. 6 females, 9 males, 1 Combine Soldier, 1 Combine Soldier Prison Guard, 1 Combine Super Soldier, and 1 police officer. By replacing one or more of these characters, we can place our own characters inside the game. The process is actually pretty straightforward and simple. Basically, what we have to do is rename our compiled models or compile our own models with these names and save them into the appropriate folders. If they are male or female, they go into the HL2MP, Models, Humans, Group 03 folder, and if they are police or soldiers, they go into the HL2MP, Models folder. It'll also be good to create icons for each of your characters. This way you can easily identify each of your new characters. Male and female icons are both saved using the names of the existing characters. Male and female are saved under VGUI, Player Models, Humans, Group 03, and then the character name. Soldiers and police live under VGUI, Player Models. Now remember that anyone you want to be able to see your custom models will need to copy these folders to their local computer, whether they're connected to the local network or to the internet. The name of the folders has to be the same in each of the computers connected to the game. It'll be best to organize with the rest of the players which models will be replaced. Then save them in a shared folder where they can be easily copied to each other's computers. So this is what we're going to do. Let's replace one of the standard male characters, as well as the police officer, with our NSC soldier. For this example, we're not going to use any LOD, because it does take a bit longer to compile. So let's use the normal NSC QC file. And what I'm going to do is change the root to match the name on this page. Under model name, I will put Humans, Group 03, Male 01. This way, it will compile into Humans, Group 3, as Male 01. Save, and now we compile. In Models, Humans, now we have a Group 03, and there we can see Male 01. Before you start the game, I recommend that you check the model viewer to make sure the model is working correctly with all the textures. Looks good to me. Let's do the same thing with the police. I'm going to copy this to the directory for soldiers and police. It's already compiled. Models. Let's put it here. And we'll rename all these files to police. Make sure that they're all named the same. Now let's replace the icons. Go to your DB Extras folder, NSC, and there's already a prepared icon for the soldier. Save it in Materials, VGUI, Player Models. First we have the police. Then in Humans Group 03, we name it Male 01. So let's check it. Humans, Group 3, and then Models, Soldier, and Police. Alright, let's try it in the game. Here we are again inside Deathmatch. So let's go to Options, under Player, select Male 1, which is our new NFC Soldier. He's also listed under the Police. We can choose whichever we want. Click on Play, resume the game, and just like the last time, let's go kill ourselves so we can get a better look. Let's also take the dumpster straight up. You can see yourself inside the game. A complete replaced character. Let's do it again. This time, we'll use a grenade. So let's see, we'll do them in the corner here. Boom. And you can see our 3D model. Alright, this time again, we have a server running with another computer loaded up with the same models and materials as mine. So now we can run around and check out our model in a bit friendlier fashion to make sure everything is how we like it. It's kind of fun. Can zoom in, run around, and he'll see me just the same. We could even give him a whack if we wanted to. So in this way, you can go through and actually replace all the default characters within Deathmatch game with your own creations. So now let's run through the entire process again with another character, since the entire process should be a little bit clearer this time around. Open Database 201 in your browser. Under Models, choose Bot. You may recognize him from the modeling exercise in our previous disk. Then open Photoshop, and we'll create his texture. Under Extras, choose bot.tga. And we're going to save this in C, Program Files, Steam Apps, Username, Source SDK Content, HL2MP, Material Source, Save. Now in XSI, assign him a Fong material. Then in the Render panel, select Texture, Image, New from File, and let's select the TGA. Program Files, Steam Apps, Username, Source SDK Content, HL2MP, Material Source, Bot. There we are. And once he's modeled and textured, go to the Valve Source menu and choose Characters Biped Guide. Scale our bot up to match. Align the feet. And remember to freeze all transformations. Now we just adjust the rig to match our model. Keep in mind that the better you align it now, the better the movement will be later. So go to the side view and make a few more adjustments. Check the top, which looks pretty good. So now we'll go to choose valve source, characters, create rig from guide. Takes a few seconds to populate all the controls. Close the windows. 8 to explore. Select the bot model, and let's set the envelope. Deform, envelope, set envelope. Click yes. I'm going to click on the envelope deformers, right click to exit. And now we're ready to export our SMD. Valve source, export SMD. And we'll place the file in the same location as before. Steam, Steam apps, username, source SDK content, HL2MP, model source, humans, male, group O3M, bot.smd. Export. Whoop, we've got an error. Select the script icon and let's see what happened. And near the bottom we see the XSI file is not currently accessible. And nothing has been exported. Alright, so go to our hard drive, temp. Let's see, we're probably going to have to change our folder options to view hidden or system files. And now we'll see the underscore temp.xsi file. We actually have to erase it. Then we can go back into XSI and export again. The file path should still be in there, so click OK. Good, and this time everything worked just fine. Alright, navigate to where we export our SMD. Program files, Steam, Steam apps, user, source SDK content, HL2MP, model source, humans, male, group O3M. In another window, open up the materials source folder. And we need to compile the TGA we saved out of Photoshop. I drag it to the vtext.exe. And once that's done, let's create a QC file called bot.qc. Leave it open a sec. In the DB extras folder, copy the QC information from the sample QC file into your new bot.qc. Paste. And all we have to do is change the model name path from humans to models. Bot. in the materials path to models, bot. Change the name of the model, bot, and the name of the file, bot.smd. Alright, now all we need are the materials. So go to Half-Life 2 Deathmatch, HL2MP, Materials, and inside the Models folder, create a new folder labeled Bot. Inside that folder, create a new text file with a VMT extension called bot.vmt. Good. Move that aside for a second. Open up your extras folder and copy the information from inside the sample VMT material file. And paste it right into the bot.vmt file we created. Change the generic texture name to bot. Save it. And now we should be ready to compile our QC by dragging it to the Studio Model executable. When it's finished, navigate over to the Half-Life 2 Deathmatch, HL2MP, Models, Bot folder, and open up the bot.mdl inside the model viewer. Left mouse button to orbit, right mouse button to zoom in or out. In the Sequence tab, you can scroll through the various animations and poses to see how your character will look, holding his different guns, or just sneaking around. And he's ready for the game.